Hmm. Thank you very much. Welcome to the lecture 16, session 1. So, in this lecture, we are going to talk about the clustering, and especially we are going to talk about the key means clustering. And this is one of the most used clustering method. And today we are going to see how this executes. All right. So, you know what is the clustering, okay? Grouping a database on their homogeneity means when the similar items are there, they would be placed into the same set, otherwise not. Okay. Just consider this example where we have just consider the first one. Okay, and there are few dotted things. So what you can say that how many different homogeneous items are there? How many clusters are there? Can you say anything? How many clusters are there? Okay. Can you tell? Anybody please reply. Can you see this data where the dotted things are there? Everything is dot. Okay, so that you don't know that what is their actual classification. But if this data is given to you, means you are not told. Huh. Is it fine now? Okay, thank you very much. Okay, all right. So I wanted to ask you this particular question that let's assume that these are the all data points that are shown to you, and my question is that can you tell me that how many different clusters are there? Can you guess how many clusters are there? Okay, can you tell me? Got the wise, Manish? Can you tell me? Just guess. Given this item, that how many uh, clusters are there? Okay, 2 clusters. All right. Yes, looks like that. Given this data, you can by yourself see that it looks like that there are two kind of data items which you can divide them because there is a lot more separation between these two data items. Therefore, you can say that you can draw a line over here, and you can see that all the items are here into one cluster and otherwise. But and this is the thing that you see that you are telling that some things are actually triangles and some things are squares, and you say that these points are square, these points are triangle. But if some information is also given to you and some more characteristics is given to you, then it may be possible that you come up in such a way that you say that these items are into one cluster and these items are into one cluster, and therefore this kind of clustering is also possible. I am just telling that this type of clustering is also possible. And similarly, if you extend this model, there would be some other conditions where you can say that no, these three items, these four items are into one cluster, these three into another, these three into another, and similarly you can say that this kind of clustering you can find out. So clustering means, by this slide I want to tell you that it depends upon your requirement. If you just see, if your requirement is such that two things are sufficient, then you say that this is the here you are satisfied with the clustering. Otherwise you have to go deep down and you have to explore more clusters, and that would be sometime in the, you can go ahead into the hierarchical method. Means initially you find out the two clusters and then you go deep down and you discover more clusters over there, and then finally you get the things. Is it clear? Alright. So our assumption is the objects that are within a group are similar, are related, and are different from the object in other groups. And then we want to find out when it is better. Means if I give this kind of clustering, then it is better, or if I give this kind of clustering, then it is better. So you know that since every data point is unique in some sense, so you can say that the maximum number of clusters that are possible are the number of data item. But this is not what we wanted to do. We wanted to give lesser number of data items, and the clustering actually is a way by which we can summarize the data item. If just say that these many data items are there, then if we find out two clusters, then we can use their representative to represent the data item into all the data using only two data items. Okay, we would be seeing this into detail. Clustering is actually unsupervised in nature. Means right answer are not known. When I give you all these things, I would not tell you that which are the positive and which are the negative items. This is only, you have to come up that how many different categories are there, and you are going to tell me that there are two categories or three categories or four categories. Okay. Sometimes if I say that these many number of categories are there, then it's your responsibility to give me the items which are there. So it is unsupervised in nature. Right answer are not known, and clustering is useful for summarization, compression. You know that as I told you that if you only can represent all the data using two data points, because it's a, you say that there are two clusters, then it's a kind of summarization. It is also a kind of data compression, because instead of using all the data, now you are only using two data points, and you can efficiently find out nearest neighbors. So there are few very high level, if you want to see that how different kind of clustering approaches are there, so you can say that one clustering approach could be a hierarchical one, and another could be a partitional. In the hierarchical one, what happens that you see that everything is there as a one cluster. But if the need arises, then you say that okay, although everything is same, but I say that these things are positive and these things are negative. And if even the need arises into division into the positive classes, then you go ahead and you can say that these are more positive, these are less positive, or these are the green, these are the red. So you can go ahead like that. But into the partitional approach, there is no high level view available. Immediately you see that only these things are there, and no further classification is possible. Alright, this happens if, for example, in your house, in your village, if you see that people are telling that this is my all the fields are there, and people say that this area is classified as owned by the Mr. X, this is classified as owned by the Mr. Y, kind of that. Okay, so you can another approach, another clustering categories could be exclusive versus overlapping, and here we see that exclusive clustering means whenever you have an item, you say that this item belongs to this particular cluster, and another item belongs to this particular cluster. But sometimes it may be also possible that this membership is not very much clear. It may be possible that with this probability I say that this site he is kind of going to be in this category, otherwise this category. Okay, these things such as you can say that if there is some crime scene and you want to find out that who is the person who has committed the crime, then there would be various suspects, and you can assign that. You cannot immediately tell that this person is criminal and this is not. You can assign that with this probability I think that he is a criminal, and with this probability he is innocent. So similarly there will be some probabilities. So if this kind of probability you are assigning with these data item, then it's a fuzzy set. And complete versus partial, this is also a very important thing. And here our approach is that if I give you data items and I ask you that partition, give me the clustering, then you say that I am sure that these items belong to into one cluster, these item belongs to the another cluster, but for some of the item you say that I don't know that whether they, what is their clustering thing. And I think this is a better approach, because sometimes you giving the complete clustering may not be the useful, such as, let me just give you an example that let's assume that here let's assume that, okay, all right, let's assume that some data items are here, okay, and some other data items are here, okay, some other data items are here, and you see that one data item is here and one data item is here, one data item is here. So if I say that give me two clusters, so what would you do? So you would find out some boundary and you say that this is the one boundary, and you say that this is the one cluster, and you find out another boundary and say that this is the cluster number 2. But you say that, okay, however these are the things, but I am not going to assign cluster to this particular item or this particular item or this particular item. This is also good approach, because it actually you by yourself see that if the cluster, if this item is cluster 1, then this item is far away, and therefore you it is not logical to say that if only you are forced to give you two clusters, then you would be giving this kind of clustering. But here you can see that they may not represent the right cluster. Okay, so sometimes if this thing is allowed to you, then you go into this kind of scenario where you say that that some partitioning some algorithms are actually let me just see. Okay, 1 minute. So sometime your partitioning algorithm is such that you are partitioning all the items, and sometime you are not partitioning some of the items. Some of the items are remaining, and what such algorithm is DB scan. We would be seeing that how this algorithm works. So in this class, in this lecture, we would be focusing on a special kind of clustering algorithm that is called k-means clustering algorithm. It is a prototype based clustering method, where prototype means that you say that I want to find out the classification of this item. This item is actually of this kind. There are some prototypes, and you assign each of the data points to one of the prototype and say that this item is of this kind. Okay, and it is a partitional clustering, means all the items are actually divided, and you immediately can say that these many number of data different clusters are there. It is not like that on the high level you see that everything is same, and whenever you deep down you find out the things are there and things are getting spread into the different clusters. And one of the most important feature of this algorithm is that user by himself specifies that how many different items, kind of item I'm looking for. And sometimes this could be a big problem also, because user when a user has a data, he may not know that how many different data items, different kind of data items he has. So therefore, if I himself ask him that how many clusters are there, then there is a problem. So we would be also seeing that there are some approaches which did not require user to specify the value of k. So here, therefore, the k means k is an important factor. And what I told you that k is a user is a parameter that the user specifies. And this is at this particular moment I want to bring your attention at this particular point that k is a very special number, and this number is specified by the user, and the system did not discloses discovers this point. User specifies that there are k different clusters. How he tells? He may be telling this because of his own domain knowledge, that there are these many number of clusters. and then your task is means the algorithm's task is to find out the items which are belonging to those k clusters. All right. So the assumption is this: that initially, let's assume you don't know that. Let's assume that these are the space and you don't know the data points. Let's assume that these are the data points that you have, and I ask you that there are three where 3k is equal to 3. There are 3 clusters. If I ask that give me the 3 clusters, so what would you do? So you would algorithm we will discuss later, but it actually it says that there are 3 things that are 3 things. Okay, and this is the kind 1 thing, kind 2 thing, kind 3 things, and every item you are going to find out that whether it is of the type 1 or whether this item is of type 2 or this item is of type 3. So you just see that every item you are going to assign that which kind of item it is. All right. So this is the prototyping. Means this is the prototype based approach. Means there are 3 things that you specify, and all the data items you are actually assigning that in which kind of it is, So this kind of there is a prototype, and this is where this is the prototype we have, and all the data items are actually assigned to one of the prototypes. And therefore, if we want to find out which are the item of the first kind, we just see that which are items are assigned to him. All right, that's very straightforward approach. I have to full screen. All right. So clustering approaches can further be seen into this way, that sometimes when you apply the clustering thing, you get well separated clusters. Okay. So this is the approach where you are getting well separated clusters. So there could be approach that can give you the clusters which are well separated. Sometimes you can get this kind of cluster. It is a center based clustering, and you see that what is the problem, that all the data items which are actually here, there is a continuity. Okay, if the data items are such that there is a continuity, then you may have a problem to find out that how to find out that whether they are into different cluster or not. Then you have to go for the center based clustering. You understand this? What is center based clustering? So I wanted to say that if I give you the data items into this way, and that is I'm going to draw the same thing. If I say that the data item, these are the data items, okay. If these are the data items, and if these are the data items, and then I say that these are also the data items, and I ask that how many clusters are there, okay. If these are the data items, how many clusters are there? So you by yourselves can see that it looks like there are 2 clusters. But if you see that, if you want to see that the 2 clusters items should be items which are near, they should be same. So you say that since this item is near to this item and this item both, therefore the classification for this item and this item should be same. Okay. So if the same, you can propagate the same logic, and therefore this item and this item becomes same, this item becomes same, and therefore it becomes that everything becomes a single cluster. So sometimes this distance-based approaches are not going to give you the right answer, and then you go for the center-based clustering approaches, where you put the 2. The K-means is a one such approach where you put the point and the representative point over here, and then it is again the I told you that a prototype based approach where you put the 2 prototypes over here and you try to see that the items which are actually nearer, they are into the same cluster. Another approach could be a continuity based approach, which tells that see these items, some items are here, some items are here, and in between there are few items. You say that this and this and all these items are same, and here look, the approach is different, therefore you are getting these kind of things. And we would fix the approach based on our requirements. You see that these items are going to be into one cluster, and similarly these items are into one cluster. So it is a continuity based clustering approach. Another approach could be a density based. You see that here there is very less items, so therefore you can see that there is a looks like a hollow. So these items are belong to one cluster, and similarly here also you see that however there is a distance, but they are into the same clusters. See, this is a very different kind of example where you see that these items are these and these items are on the same cluster. However, see the distance between them; they are not connected. Okay, this is happening because you see that the density base. If the density is very low, then you say that these items are the same item. So this is most of the time you can use such as malignant tissue detection into the such as cancerous tissue detection into the some fields. So you can see that these and these items are the same items. You can search for that. Here you see that the density is different, therefore these are all these things are connected and therefore they are into another cluster, and you see that these items are here the density is much higher, therefore they form the third cluster. Another approach that could be a clustering approach, that you apply the conceptual clustering. You say that the items are actually they belongs to a special kind of shapes, such as here you say that the items could be only of the shape of triangle and the rectangle. So these are the rectangle. So you see that these are the items and these are the items. They are very different. Otherwise, it looks like that all the things are the same. But if you apply some conceptual things, such as here, you see that you think that my data is going to be into the ring format. So how can you apply these kind of things? Again, many of the time I'm reiterating this thing. Okay, I'm reiterating this thing many of the time, that all these things, that which kind of application, which kind of clustering I need comes from the domain. So you know that my data is of this kind. Therefore, you are going to apply these kind of techniques which can have the conceptual understanding. I got a question. Let me just answer that. What is the role of density here? Please explain. Okay, all right. So I say that sometimes you need the clustering. Sometimes you need the clustering in such a way that the places where there is a high density, you are going to say that they are having a different cluster, and such as I told you now that into the medical domain, if you want to get a tissue, so you want to segregate them into different parts. Okay, so you say that I don't know much about this, but I'm just having a guess that there could be a different kind of things available. So based on the density, you say that this is one kind of item and this is the second kind of item, like that. So clustering is one of the biggest example. Usefulness of the clustering is into the segmentation, because when you can cluster that these things are the same, then you can cut those parts and say that this is the one thing that I got. All right. Another question, sir. Center-based clustering approach is not clear. How are differential for the well-separated? How are they different from well-separated clusters? Okay. All right. So very good question, that what is the difference between these two approaches. So here I am telling that the things are well separated. So if you say that if I want everything well separated, okay, so this thing is one cluster and this thing is another cluster. You agree with this, Manish? Okay. If I say that I need well separated cluster, what does it mean? That there should be a difference between them. But if these things are going to be connected, means if there is very less distance, see these examples. Don't go for don't see the classification. Just see that these data points are very near. What would happen? Would you be giving me the two clusters or a single cluster? My question is that if your data is into this way and you want well separated cluster, so how many clusters you would get? You would get only single cluster, because they are not well separated. Because you need well separation. Now there is no well separation, because items here, they are actually overlapping. So how in this, if data is of this kind and you want well separated cluster, so how many clusters are there? Manish, can you answer? One cluster. All right. So however, you can see that it's not the case. As the data you see, it's not the case. It is a two clusters are there. So to tackle this kind of problem, I told you that we can go for the k-means clustering kind of approach, where we have a prototype based thing, and this actually applies the center based clustering approach, where you say that there is one center point, there is also center point, and the points which are nearer to the center points belongs to one cluster, and point belong to another center belongs to another cluster. And then you say that these points belongs to one cluster and another cluster. All right? Okay. So we have discussed this, that there could be various clustering approaches, and they all are very equally valid. So we are going to see much details of this particular algorithm, that is called the k-means clustering algorithm. I told you that k means how many clusters are there is actually provided by the system designer, and who is actually the user. Okay. So the k-means algorithm is this. Okay. So initially I would not go to this algorithm. I would just go to the I would go to this particular place, and I would initially tell you the algorithm, how it is happening, and then we would see the algorithm. Okay. First we would come here, and then we would go to the algorithm. All right. So let us have some data points. So let me have, this is a data point, this is a data point. Let me have some data point. Okay, I don't know that. Okay, let me have some data point. Okay, looks like that these things are connected. Okay. Now my question is, can you give me 3 clusters? K is equal to 3. I am going to talk about k-means algorithm. K-means algorithm. Okay, so what is means over here? So we will be seeing that. So I told you one thing, that this algorithm is a prototype based. So I need some prototype. How many prototype I need? K prototype. K prototypes. So where are those prototypes? I don't know. So let me put some prototypes. So how can I put the prototypes? So you can choose any location. Let's say randomly I pick this particular location. This is the one location, and randomly I pick this particular location. Randomly pick let's assume that I found another location. Can you give me another location? Say I found, because it's so many space I have this location. All right. So these are the K prototypes that I have. So how I put, you understood that how I put the prototypes? Everybody understand this? Say yes. If you don't understand, please let me know. What I told you, that let's assume that these are the data points. Now I need K prototypes. Okay, because this algorithm is a prototype based algorithm. So I have where to put the prototype. Randomly I have find out some places, and I have put that. Okay, now each of the data items should be assigned to the prototype, because I am telling that this item is of this type, this item is of this type. So every item should be assigned a prototype. Okay, so let me to segregate them, let me give different colors. So let me give, there is a prototype which is let me a prototype that is green prototype. Let me have a prototype that is a red prototype. Okay, a red prototype, so that we can differentiate now. Let me prototype that is blue prototype. These 4 prototypes I have. So let me find out that which items are going to, because if every item need to be given a prototype, so if which item I have. So this is an item. One by one, let me consider. This is an item. Okay, this is an item. So which item, which prototype it is associated with? How can I find out? So one simple way, that you see that what is the difference between what is the distance of this item with the prototype. So you can measure that, the distance. Okay. Okay. Again, I have a very big point for you, that how to find out the distance. One way is the Euclidean distance. The simplest way is the use Euclidean. And you know what is the Euclidean distance. You just measure distance. So if you measure these distances, so can you tell me that which kind of what should be the prototype of this particular item? Can you tell me? How many prototypes are there? 3. Okay, K is 3. What are these prototypes? Red, green and blue. So for this item, what is its prototype? If you use the Euclidean distance as a measurement, I'm getting the answer as a red. Everybody, anybody else? Okay, I got 2 answers that it should be red. Anybody more? Anybody else you want to tell that it is a different thing? Let me tell you one thing that I have drawn a line that I'm going to use the Euclidean one. If I'm not going to use the Euclidean one, Euclidean distance, then there could be other ways, such as Euclidean is a simple square thing. Like you can use a norm, so simple norm and other distances, so they can give you something else. So in this assignment, you see that this item is actually, I don't see, I cannot say Control Z. Okay, all right. Let me just a bit. Okay, so this connection does not have any meaning, so I would remove this connection. This is also not going to work because when I have find out this is not the right thing. So this item is actually assigned to this thing. You understand this? Okay, okay, all right. So is it clear now? Now, what is the prototype of this item? Can you give me? Green? All right, very easy. So now you are very quick, and I am very happy with that. That you told me that this item is actually assigned to this thing. All right. What about this item? What about this item? Same, green. Can you tell me what about this item? What about this item? This item? Red? All right. I agree. What about this item? What about this item? Looks like red. Also assigned the red. What about this item? Looks like that is going to be assigned over here. What about this item? Assigned over here. What about this item? Assigned over here. What about this item? Assigned over here. This item assigned here. This assigned here. This assigned here. This assigned here. This item is assigned here. This item is assigned here. This item is assigned here. Acha, what do you mean with the assignment? Because I can write here that it is assigned over there. Okay. So this item, I think you would be telling that it is assigned over here. This item is also assigned over here. For this item, I think that this is only possibility, and this item, I think there is only one possibility. This item is also only one possibility. It's also one possibility. This item, I think, would be assigned here. This item looks like that it would be assigned here. This item should be assigned over here. All right, we have done one step that all these items are actually got the assignments. So this is the one thing that now we know that which item is assigned over here. Okay, so we know this. Okay, you are with me? Everybody understand it up to this point? Okay. All right, very easy. Now these prototypes are not good. Because why they are not good? Because if this particular item, this is representative of these items, so why he is sitting over here? He should sit at that place where the distance is minimized, because he is the prototype for these items, so therefore he should not sit here. He should sit at that particular location where the distance is minimized. Can you see this? Would you be happy? Would you understand this? What I want to say? What I'm telling? Would you like this point? What I'm telling? Just see this. Let me just take this, all these things. That this green one is a representative of these items. Okay. But he is setting such a distance place. What is the right place where this green should be? So you find out the the best point is the middle point. So middle point you can find out by finding out the summation, because these items are actually x and y. Every data point is actually contain x and y coordinate values. So you just find out the summation of x and divide by the number of items, summation of y and divide by number of item. So by this you can get the center. Okay, so you see that centroid of all these points, because these points which are there, maybe somewhere we see find out the summation of all the x, maybe somewhere here. Okay, so you would see that why this particular green one, Mr. Green, is standing at that very distance location, because he is representative of these items. So why he is not shifting to this point? This particular point should shift to this particular location. So you are actually telling that this is not actually, if you are representative, so you should come near to me. You should sit here so that you become the more representative. Now earlier you were the difficult to find out. And now you are my representative, therefore you should be here. So you understand one thing, that there is a need that representative should be near. Okay. Similarly, can you help me to find out the same thing over here? So I told you that this is the boundary. This is the boundary. This is the boundary. So let me remove this part. Okay. So this item, I say, let me remove this thing. So again, if you want to find out that what is the centroid, so for these items, these are the items that you have. For these items, you have to find out that if the summation of x you say and divide by number of point, I think you would be somewhere here on this line. For the y, I think the middle point is this, so it would be somewhere here. Okay, this is what the centroid is. So you say that the centroid should not belong to this particular place, it should belong to this particular location. So are you happy with this approach, that I am telling that centroid should not be there, it should be here? No? Because it's the representative, and if it is a representative, it should be near to the point, so that there should be no much difference, because representative, it's a prototype, it is representing the item, it should not have the much difference. That's why I have moved this location, because anyway this particular location was not my choice. Initially it started with a random thing, therefore it is better to have this particular item over here. All right, so we have done this particular solution, and then similar kind of adjustment can we do for the red also? Okay, so we should go ahead, try to see that these are the points, and I want to find out that what is their centroid. So can you help me to find out that what is the centroid point? I told you that to find out the centroid, what is needed, that you find out the summation of 1, 2, 3, 4, 5, 6, 7, 8, these 8 points. For these 8 points, you find out the summation of x. If only these points were, the summation may have somewhere here, but since one point is also there, so therefore I think the summation of x would be here, and summation of y, I think because of this summation of y should be here. It could be here. So I am just having a rough estimate, so hope you would be agreeing with me that error is possible, but it looks reasonable to put these things over here. Okay, all right. Okay, so let me just remove this. And I say that, okay, you are representative of all these items. So why you are so distant? You should come closer. So this item came closer, and now you see that this is the new location for this item. For the representative have changed his location, and now he is here. I am removing these things. Why? Removing these things because, okay, he is representative of this thing, but nothing is permanent. Okay, now we are into this scenario. Okay, all right, we are into this scenario where you have seen that you had an earlier position. Initially you had a position, and now your representative are this. Now let me do the competition once again. Okay, let me find out which item is going to be assigned to which item. Alright. So again same exercise I am going to do, and you have to help me to find out that. So I see that since these items are nearer, so they are here. I think I should not take this. This item is here, this item is here, this item is here, this item is here. So I can give you a trick that you just find out the middle point over here, and you can draw a line from that. And similarly from here you see that this is the area where if this would dominate, this is the area where this item would dominate. So you see that this is the area. So you see, because of this domination, what is going to happen? These items are going to be assigned to the green, and you see that the assignment had changed. Now it is not the same assignment that it was earlier. So these items are actually assigned to this particular thing, and now these items are assigned to this particular data item. All right, this particular thing. Simple. Can anybody write? Yes, that it's easy. It's easy. So you understood that how I am doing this, all these things. All right. Now what would happen? Now what would happen? Same thing, because I'm telling that this particular item is actually assigned. This particular item is actually representative of these things. So if you want to find out the summation 1, 2, 3, 4, 5, 6, 7, 7x values, and if you want to find out the summation, so you can think that now the x would not be here, x would be a bit shifted. So x would be shifted, and I think y would not be much shifted. So you can see that the representative would move into this particular place. Alright, because this is needed. Otherwise, because if you find out the summation of all the x and divide by y, so this would move into this place. So alright, this is going to happen. Okay, so let me remove this. Alright. Alright, let me also remove this because this is just alright. So next there are the next points are these points. These are the points. So where should be the centroid? I think the centroid is at the right place. It would be very little shifted. So I think new location could be, because these are the points, I think it would be not much shifted. Okay, it looks like, na? Because you help me to find out that. I think let's assume that it is here. Okay, it is here only. So if we remove rest of the part, I say that this wicket. Alright. Okay, let me remove this. So I see that assignment is, why I am killing the assignment? Why I am killing the assignment? This is a big question, because you should ask that, sir, if they are assignment, then why you are killing the assignment? Because I am killing the assignment so that the new assignment could be given the data item. Okay, because it may be possible we have randomly initialized, so there could be the wrong assignments. But you can see that there would be a huge shift into the red one, because now only these points are there. So you see that the centroid would be here around. So you see that the point is here. By yourself you have seen that it has happened. Alright. So this is how we have done. Okay, great. So sir, how it is different? K and N. Arey wah, gajab question. You have asked very good question. Manish has asked a very valid and very important question. Ki how it is different from K and N. Okay, how it is different from the K and N. So Manish, please hold this question for some minute. We'll be discussing this into detail after some time. So, and please hold this question and please keep it and ask before we leave. Okay. So at later point of time we will be coming to this particular point. So let's finish this algorithm first. So can you tell me that what is going to be the next step? Can you tell me what is going to be the next step? Again, the same assignment and the same thing. Okay, recenter, recalculate the things, and as you know that I can draw the line in between, and I say that this is the line. Here I can draw a line like this, and in between I can draw the line like this, and then what would happen? You see that using these points, this centroid would shift. Again, you can see that there will be a shift in the centroid. Centroid would be here, and now he would be held holding all these items, and then centroid would not be here. So this is one thing, and here you can also see that the centroid would be for these items, since it is a centroid of these items, so it would be somewhere here. These things, okay. So centroid would not be here. It goes a bit further. All right. Okay. And this green one, what would happen with the green one? It would also shift, and I think it would shift to this particular location. This location. All right. So this is going to happen. Okay. Again, same thing. Again, we have to do the same exercise. We have to find out that which points are assigned to which, and we have to go ahead. But I think now it is a bit, everything becomes fixed, because now if you apply the algorithm again, here nothing is going to change, because these are the points, nothing going to change. Here also you see that only these points are there, and therefore it is also not going to change, nothing going to change. So now you have your centroids. These prototypes are actually centroids are actually got saturated. So you stop when you see that saturation. Okay. So you stop when saturated. You see that the saturation has achieved. Now there would not be any change. All right. Now I can tell that any given item is assigned to which item. Okay. So now I can say that since user has already given me that, give me the 3 clusters, so I can find out that these items are into one cluster, these items are into second clusters, these items are into second clusters, and these items are into third cluster. So I would say that take these items and say that these items are into this cluster. Now a very important question is there, and that is a very, very important question, that what would you do with this kind of clustering? So it may be possible that at some later point of time a point came, this was a point, and I want to find out what is the clustering, what is the classification of this item. So all right, looks like it's easy problem, because you can say that I would just the measure from control set. I would you can say that I would measure the distance of this item from all the centroids only. Okay, and try to see which is the minimum one. So it looks like that the minimum one is this one. So therefore this particular point is assigned blue. Okay, it is assigned blue. Everybody understand this? Can anybody tell? Yes, you understand this? We have used this clustering to find out the classification. Okay, and in this classification, how many items we have considered? Okay, did we consider the nearest neighbors? If I wanted to find out the clustering of this item into the previous setting, what was needed? That the 3 items, 3 nearest items need to, you have seen that the algorithm in the last class, that you need to find out the 3 items which are nearest. So which are the 3 items which are the nearest? So if you grow the circle, you see that these are items, these 3 items are actually your nearest item. Okay, and you do the voting, and you see that the classification of this item, again the same classification, that is the blue only. So this also you see this is the approach to find out the classification. Okay, so this is KNN. This is KNN. KNN. KNN is a classification approach that find out the nearest item and try to see what is their classification, and then gives you the right answer. All right. So if I okay, so this is the classification algorithm. KNN is a classification algorithm. However, K means is a way that gives you these clusters. Clustering. So these both the algorithms are different algorithms. One algorithm is used for the clustering, another algorithm is used for the classification. However, this K-means clustering can later be utilized for the classification, but that is altogether different matter. Okay, so we are going to have a break at this moment. So if you are ready, we can have a 5-minute break and then we can reconnect. So is it right? Can we take a small break at this moment? All right, thank you very much. Okay, so we will be reconnecting at 8 p.m. sharp.